The method was approved by AfN in 2022, so just in May, and we believe that this method leverages the strengths of both the drone, the vertical view that you can take from the air, and the on-ground field measurements. And we certainly believe that it'll be a lower cost, more accurate way to monitor vegetation health on large properties, because it does allow that carbon sampling as well as the vegetation sampling. As I mentioned, we started this trial under the Land Restoration Fund method, and at that point we were applying the AfN vegetation condition method, which was the LRF version. And we couldn't make that work to generate an econ on these really large pastoral properties. Not only was the mapping not consistent when we got out there, but we found that the approach just wasn't fit for purpose on a really large properties. And we'd also learned from the work that we'd done in developing our first AfN method at Urardi in Western Australia, where there aren't benchmarks and the mapping is really not great either. So we were learning things as we went, and we could see that there was potentially a better way forward. Obviously, working with Climate Friendly, they already have an approach to stratifying properties for their carbon purposes, and under the carbon requirements, the accuracy of those stratifications has to be 80% plus. So we certainly had things to learn from Climate Friendly to support the development of this method. And the other thing that we were watching jealously as field analysis was being undertaken with calipers and tape measures was we were watching this drone go overhead and thinking there's got to be a better way than what our ecologists were being put through. If they can collect that sort of information with a drone, why can't we be using it as well? One of the really beneficial things of this method is that we're collecting potentially over 10 times more data per area of assessment than what you would get in a Queensland biocondition plot, or under our existing method, it's 20 times greater. So we do think that we're collecting just a massively large amount of information that is applicable when you're looking at properties that are greater than 20,000 hectares. What we're doing at the moment is applying this to our own bush heritage properties and some of Climate Friendly's clients. And by the end of the year, we hope we'll understand better the cost savings, and we'll also have better data around the accuracy and precision of this. And we hope that it will meet our expectations, but that we'll be testing those hypotheses and we'll have that data by the end of the year. Obviously, the key, which I've also already sort of mentioned about this method, is using the most suitable tool for the job. And when we use the satellite imagery to classify the vegetation and understand that spatial extent, that's eminently more useful for us than, for instance, and this is in no way being disparaging to the Queensland Herbarium, but the maps have been developed from some very specific points and then extrapolated out across almost half of Queensland. And that's always going to lead to some errors. So taking this approach with the satellite imagery is really helping us to focus down and make sure that we're stratifying appropriately. We're also then able to use the drone footage to get really high resolution of that 3D imagery to get the structural information and percent cover information that is naturally already quite difficult for an ecologist to do accurately. So we're using the right tools there with high accuracy to get the right information. And the thing that the ecologist really does best is actually assessing for species composition and richness. So we're using the skills in the right way, we think. Excuse me. Application at the moment, it's that this method is applicable to open forests, to grasslands. We are looking at how we might be able to extend it to closed canopy forests using terrestrial Lidar. And that's some of the work that we'll be doing through the rest of this embargo period. It's obviously applicable to conservation properties like bush heritages, but also to agricultural lands, and clearly also to agricultural lands that are running human-induced regen or integrated farm method. The range of properties is again, we're going to work out on costings for how small you can go, but certainly can go to very large property ranges. And importantly, it considers threatened and ecological communities, which from a bush heritage perspective, but also from climate friendlies, this is really important for us to make sure that we're appropriately measuring and monitoring those threatened ecological communities. And as you'll see as we go through in a bit more detail, we do believe it's applicable to all of Australia. And that's because of the way we're looking at reference, which we'll provide a bit more detail on. And as I said, I think it'll develop cost savings, and particularly where it's applied with the carbon methodology, because one pass gets you both that vegetation data and that carbon data. I'll just hand over to Jay, and he might provide a bit more context and take us through the map accuracy and stratification.
Thanks, Ange, and thank you everyone for coming today. As Ange mentioned, there's some lessons, I guess, that we've learned from trying to accurately map carbon properties that we've tried to apply through this method. And the image that you see there is unsurprisingly a state boundary with what's effectively the same vegetation on each side of the state boundary. So one New South Wales, one Queensland, but the vegetation is actually consistent on either side of that border. The state maps are different simply because they're applying different algorithms to the same vegetation communities. The reason why this is important is it does make using state reference maps somewhat fraught if you intend to move and apply things that consistently at a national scale. So the method doesn't require you to ignore state-based vegetation maps or NVIS. It just allows you to consider them as well as other information that you feel you could use to best group like vegetation communities on the ground. So in reality, this could be bringing in flood zone mapping, soil types, as well as vegetation cover in undertaking that work. We also have learnt through that mapping exercise with carbon that it's important to actually validate the accuracy of your maps and not just assume that they're correct. As Ange touched on, when we applied some state-based vegetation maps and we went into the field to try and apply the LRF method, what we found was the maps were actually more inaccurate than they were accurate. So they had less than 50% accuracy, which for anyone dealing with statistics will understand that that's counter to the point of stratification, where you're meant to group like things together. So through those lessons, we've created a stratification process in the method that's flexible, but requires you to actually validate that map accuracy once you've created your maps and prove statistically that it's at least 80% accurate. Next slide, Ange. So at a very high level, the process is you will define your property into an accounting area. You will first identify any threatened and endangered ecological communities on there based on the best available mapping, which generally is the state mapping, which isn't perfect, but that's the start. If you identify any more in the field, you'll add them to it. So they're quarantined and they get special treatment later on. You then consider the land use history on the property. So that could be fence boundaries within your property. It could be clearing history on these large properties is something that can be quite easily defined. And you segregate your property into those different land use histories. Then you consider state or federal vegetation maps, as well as the other information sources to create your map, which effectively aims to identify similar vegetation types under similar management activities in the past. So in a theoretical world, you would get a nice, simple, pretty map like this. In reality, they're a little bit more complicated. But the aim is to not have a phenomenally large number of strata. The aim is to try and minimise that number, but still have them as like as possible. And we're finding in the rangelands that we're ending up with between sort of 3 to 5 strata when we're applying this approach. In terms of the actual sampling, within those strata, we are assigning UAV plots, and we will probably alter the method to allow airborne LiDAR as well. And you're assigning random plot locations within those with which you will fly your UAV. And you're collecting between 5 hectare plots. We're looking at giving some flexibility on the size of those plots, which is significantly bigger than what you can sample within a reasonable time frame on the ground. The ground-based assessments is of a smaller area and preferably tied to that sample location with some flexibility, noting in practice you might be able to get a drone into locations that you can't easily walk, such as due to rivers or escarpments or other issues. The data that we're getting from our UAVs has two key elements, and I'll show them separately as we move through. But the image on the left is a UAV collected RGB image from a drone, and this is in a rangelands property. The colour spectra has been used to classify bare ground, grass, shrubs, trees within that middle image. So that classification in the middle image there is 1 bar on that graph to the right. So for each of those sample units, you end up with a classification of some of those structural elements there, repeated multiple times across each strata. Next one. The method, whilst it's not prescriptive that you must use LiDAR or RGB, you can use a combination, and certainly we think that LiDAR is extremely powerful for accurately measuring the structural elements of vegetation condition across broad areas. So these are some screenshots provided from a LiDAR provider, just giving you an idea of the granularity of data and the scale of data that you can get using LiDAR across these broad properties. So the left-hand side gives you an idea of the area and volume of data on structural integrity, which you can convert to things like the diagram on the bottom left, showing you different tree types and structures. On the right-hand side, you can see that even grass and deadfall and litter can be reasonably well identified using LiDAR data and algorithms to convert it to specific metrics. So whilst the method's flexible as to what UAV tools you apply to them, we think colour, spectra and LiDAR is the most likely successful combination.
All right, I'll take over there. Thanks, Jay. Thanks, Ange. So obviously merging the field data to create this account means that the on-ground people can really now focus on the composition information. So collecting this sort of data collecting species information is often either done too rapidly so that you don't get full detail of the species composition, or you spend a long time collecting that data that we can now collect using the UAV, and you collect that field sample stuff. So we're hoping that the time spent in the field by combining these two approaches will really speed things up a lot more, and we'll get a lot more detailed information. Thanks, Ange. Yeah, so the the measurements we get can be sort of split into well, 2 or 3 groups really. So the extent or configuration, as we've spoken about before, really dependent on the satellite imagery. That gives us the stratification, if you like. But then the composition of information, we are breaking that up into the structural stuff, which the UAV is going to collect, which used to be the very tedious job, I have to say, having done a lot of this work, measuring, tree DBHs, measuring line intercept, cover, those sorts of things takes a long time. Not necessarily very accurate, but if done very carefully and methodically and very over short distances, it can be very accurate. But with the UAV, again, we'll be able to sample over 5, maybe 10 hectares. So it's a much broader scope. So as I say, just doing the composition stuff on the ground with expert botanists means we get that species composition information really down pat, which means we can measure things like species richness and the weediness on the ground, as well as differentiating things like the litter into different components or areas that come up as in the ground cover up into the different categories that we're measuring. Thanks, Ange. So this just gives you, this diagram's a bit, this table's a bit complicated. If you just concentrate, that middle column is effectively what Bush Heritage currently does, or is moving away from, I should say. And the last column, the IVC, this current method we're talking about. And we've just put in a couple of different indicators, C, K, D, and F, doesn't matter. We measure about 13 different indicators in this method. So just to give you an example though, so for say tree canopy cover in the past or currently, we measure just using a line intercept method, 50 metres, 100 metres long. As I said, quite a tedious process, whereas the new method, that's going to be totally done by the UAV. We don't feel there's a need to sort of do any kind of verification, if you like, of what the UAV is doing. It will do a better job than over a big area than what we can possibly do on the ground. With the number of plant native species present in the shrub layer, the canopy layer, again, we're pretty much dependent on using those line intercepts and quadrats, but again, only sort of a 50 by 20 metre area. So in this new method, we'll be using roughly the same sort of quadrat area, but it will all be quadrat based. It won't be any line intercept method. So we should pick up a lot more species when we move from that method to another. There is the ability to use, if you want to, use the state-based vegetation condition assessment procedure to measure these things as well in the field. So that means you can use the benchmarks, for instance, that are available for each of the vegetation communities there. For native shrub cover, again, it's the same sort of thing. We've got the line intercept method used currently, moving to the UAV. What we'll do with that, though, is still require a bit of on-ground work, and that's just simply where we have, say, weedy shrubs, non-native shrubs to the area. We'll be able to determine the proportion of native to non-native species there, and so we can scale the information we collect with the UAV to give a much more accurate figure on that. And finally, with things like native canopy species recruitment, we currently, well, we do have a method at the moment with Bush Heritage, but it's much smaller recruitment, just like seedlings, if you like. Whereas in this other, with the new method, the IVC method, we'll be doing that over again at 0.1 of a hectare, and we should be able to, again, using the drone to detect that. Using, saplings, I suppose you would say, up to about a metre high per hectare. Okay, thanks, Ange.
Thanks, Matt. As you would all be aware, or those who are experts of AfN would be aware, reference condition or benchmarks is really important to be able to generate an econd, or at least indicated condition scores in the first instance. And the way we're approaching this is, again, sort of based on the experience that Bush Heritage has had from trialling accounting for nature approaches at different places. I should have said right off the bat that the approach that we took from this, because we were working with the LRF at that time, we used by condition assessment, so the Queensland state assessment method for vegetation condition assessments as the sort of basis. And they're the, I think it's 12 indicators that we were trying to replicate using this new approach. But the other thing that we had tried to do in Queensland under the LRF pilot was to use their benchmarks. And I haven't checked most recently, but the herbarium then removed their benchmarks from the website, so we weren't even able to access them, and have reduced them to a point based. So rather than they used to be a range, and they're moving towards providing a point. And we've sort of found that a bit problematic for the purposes of an AfN account, because of course there will be natural variation through even a year, and depending on when you're going out to assess, you could have, you know, a difference from that 1 point. And so we've considered that actually the best approach for reference condition is to have some type of paired reference site, whereby you're measuring the reference at the same sort of temporal time as the target site. So we consider that sort of the best on offer reference, and we've got some criteria in the method around it being within the same IBRA region, within 100 kilometres of the target site, that it's assessed as by an expert as being in reference state. And there are others that are slipping my mind at the moment, but we do think that that's a really good and important element, because seasons will go up and down, and by having that reference, you can actually track that over time and see also, you'll have the data about what is actually happening to that reference site over time, which I think is an important element of data more generally for us tracking climate change implications. You can obviously still use the static condition benchmarks that the state defines, or there might be other definitions of those. They can still be accepted. And into the future, I think there's the opportunity to have a hybrid approach between having a reference site that you know is in reference and monitoring that over time, so along with rainfall and other variables, so that you can model what that reference state would look like, and therefore allow for seasonality. And I think that's going to become more and more important as we undertake these projects across large areas, and hopefully they're replicated across not just Climate Friendly's portfolio, but others. And the opportunity to have reference sites, and plug for a Bush Heritage property being a reference site, that can then use its data and provide that to third parties so that they can undertake their own econs without having to necessarily go and collect that data themselves. In terms of sampling frequency, again, we're allowing some flexibility around climate variability. Obviously, you'll get a very different response at the end of a drought than you will after a first flush of rain. So, there would be sense in doing it not at the end of a drought, so that it's probably not worth wasting your money to go and be doing data collection at that time. We also have a recommendation that threatened ecological communities are monitored more frequently, because they should be. But that on average 5 years is what we would see. Obviously, over time, the structural elements will change slowly, and the compositional ones will go up and down with those seasonality. So we're just trying to sort of find a balance there. So who cares, and will it have impact? Well, we hope so. And obviously, Accounting for Nature thinks it's a pretty good method, and they've had considerable interest. And it was lovely to hear, although frightening for me as presenter, to hear that there were 70 responses to this webinar. So as we understand it, most of the interest is coming from large pastoralists, but we've also had interest from governments as well. So we intend to keep talking to them as we're developing the method further. We certainly hope that it will be picked up by the federal government biodiversity certification scheme, and we'll be advocating for that. And I think there's lots of opportunity under a method like this and under sort of an AfN or a certification scheme, whereby, as I've sort of mentioned, there's opportunities to provide for organisations like Bush Heritage who have sites that we're managing, hopefully to get them into reference condition, that, you know, that's now valuable information for others who are looking at comparing themselves to reference. We also think that there's a great opportunity to align the sampling for integrated farm method, management method under the carbon method, that would allow for that cost efficiency, but you would obviously be able to align the two certifications to have a sort of diverse carbon project. And in using the best on offer reference, there's also this opportunity for farms themselves to create their own reference site within their management units. And that would be, I think, a great thing to incentivise through a project such as this. More broadly, and this is thinking very big picture and not immediately, but and assuming you can fix all of the data privacy issues, I think there's a really big opportunity, if this is played out across large areas of land, to improve the calibration of remote sensing tools that we're currently using, both for carbon and for biodiversity, and also opportunities to learn from such a big ecological data set that we'll be generating across, you know, large hectares of rangelands and other properties across Australia. So we're very much open to your questions. I should also say that this wasn't just Matt, Jay and I who just whipped this up overnight. It was an absolute team from both sides. And on the call today, there's Mitch Rudge who works with Bush Heritage. He's a PhD student at UQ. And I can see Andrew O'Reilly-Nugent from Climate Friendly on the call. And I'm sure Sam's, oh, gone, what's his last name? Sorry, Sam. Help me, Jay. Will also be on the call. So if there's people who, if I can't answer any of your questions, I'm very much hoping that Andrew can come off mute and help me with any of the questions that you might have. But it was very much a team effort, and I really want to acknowledge everybody for their hard work. So back to you, Amanda.
Thank you so much, Angela, for that presentation, and thank you to Jay and Matt as well. I thought we would open up for questions. We had one question from Ingrid waiting in the chat for some time that I thought we could start with. And so she's asking what type of carbon data that can be collected from one pass of a drone.
Well, I might pass that over to Andrew. Obviously, it's biomass data that they're collecting, but Andrew can provide that detail.
Yeah, thanks. So we use the drone in this method particularly focuses on the structural elements. So that's tree size, tree height, tree number, as well as the shrubby understory. And then in the sense that we use it for carbon monitoring, it's the same input information, but we're just calculating a biomass quantity rather than comparing it to a reference site per se. If you'd like more detail, Ingrid, feel free to ask again in the chat.
And I was going to say to anyone who might think of a question after the session has ended, feel free to send those questions to Accounting for Nature, and we will pass those on to Bush Heritage and Climate Friendly.
And I should just mention that I think Jay's had to leave. He had to go and pick up children today, so he's stepped off the call.
Any other questions?
Can you hear me?
Yes,
we can.
Hi, sorry. I don't use Zoom very often. It's Liz Pride. I'm a technical lead here at Greening Australia. Really lovely to see this work being done. I was just wondering, in terms of collecting data on the reference site, this is something I've also been thinking a lot about. And it's obviously needs quite a lot of resourcing. And I was just wondering how Bush Heritage had worked with that, and what you thought about, you know, things like collaborations. Often, you know, a lot of these NGOs work in similar regions. So yeah, just wondering how you thought about the resourcing for that type of work.
Sorry, Liz, I think you're sharing your screen.
Oh, am I?
Sorry, I was looking at that, trying to integrate what you were asking, and
Oh no, it's not my.
Confused.
It's not my screen. I'm not sure whose screen it is, but it's not mine. So that's a relief.
Okay, cool. Sorry, Liz, could you please restart your question?
Yeah, no problem. Yes, so sorry, it was just a question with respect to the reference site. So this is something I think about a lot as well, and obviously the benchmarks are kind of like a cheaper way, or you know, to do that. And as we all know, monitoring can be quite resource intensive. So I really like the idea of having those paired reference sites and, you know, counterfactuals and controls and things like that. And just wondering, you know, is there any thought about having an open, a sort of an open data collaboration type scenario where different organisations can collect those references? Because often those areas of works overlap, I guess.
Yeah, I think Accounting for Nature might want to have a word on this, but I've been saying what a great idea it would be for organisations that have got reference sites to be able to make that information available, and possibly either through Accounting for Nature or through the user of that information, there might be a little bit of a passback to help us to keep it in good condition. And that's certainly something that, yeah, I've been encouraging Accounting for Nature to consider.
Yeah, that's great. Thank you.
Yeah, it's definitely something we are looking at doing, and in particular in those areas that don't already have state reference benchmarks. I know in Queensland, New South Wales and Victoria, we're quite fortunate in that a lot of ecosystems do have them, but other states just don't have that type of data available, such as WA. So we're definitely looking at how we can make a publicly available library, and then hopefully and potentially even provide some compensations for people or farmers who do maintain those sites at reference condition.
Great. Thank you.
And just want to acknowledge Sam Shumack, whose last name I couldn't remember before.
So we had a few questions pop into the chat. Andrew was very kind and answered Ingrid's question regarding soil carbon, but we had another question from Paul Webb asking, would you see scope for regional desktop-only assessments as benchmarks, then complemented by smaller scale, more detailed assessments with UAV or Lidar field data?
Yeah, potentially. I mean, I think if we've got good data that can justify those benchmarks, then we'll use it. And to date, you know, the state benchmarks aren't a bad thing, don't get me wrong, but they don't necessarily move with the seasons. And the ranges then can also make it difficult to understand, you know, when you should apply what end of the range. So I just think that having some good thought through analysis about what the benchmark should be in real time, given the conditions out there in the field, would be great to have. So that concept is kind of what I think we're looking at with that hybrid approach. So yeah, all up for that. I think, you know, like I see this as it's certainly not just a bush heritage and climate friendly thing. This is something that needs to be sort of sector wide and work with NRMs and others to collect the right data and have it on hand.
Just to add to that, I think we certainly see the desktop assessment as part of the identification process for a good paired reference site. But until we have that big library of data collected, I think it's going to be using that to identify where to go and sample, like you suggest.
Any other final questions before we wrap up? So we got one from Ben in the chat. In your liaison with the government groups and federal, do you expect that there will be a single assessment and monitoring method to support the anticipated natural biodiversity credit scheme, or multiple endorsed methods?
Do you want me to cover that one, Ange?
Well, maybe Accounting for Nature should cover that one.
What's that?
Maybe Accounting for Nature should make a comment on that one.
Yeah, sure.
Yeah, thank you, guys. So it's a really tricky and good question, Ben, and I think it's still in such early days of development that we really don't know yet. I think we are as excited as the rest of you to kind of find more details on what this biodiversity credit scheme will actually entail and how it will be rolled out. And I think from the Accounting for Nature perspective, we really want that rigor behind any biodiversity credit scheme. And hopefully that can come through the proposed biodiversity credit scheme with the government. But yeah, we still need to wait and see what actually happens with that development.
Yeah, and just on the actual method side, in practicality, I think you could not possibly make a single method to rule all environments, all cost profiles, and all property types. So there's, as well as fauna and flora. So I think there will always be multiple methods, but we would hope they don't create 40-something methods like you have in the carbon scheme at the moment.
Okay, if there are no further questions on today's session, we might wrap it up. Thank you all so much for joining and listening in today. And thank you especially to Ange, Matt and Jay for presenting. Again, if you do have any questions, please feel free to send them through to info@accountingfornature.org, and we will pass anything on to Bush Heritage and Climate Friendly. So thank you so much and have a lovely afternoon, guys.